Hey y'all, welcome back to video 16 of our series. This one gets to one of the most important topics in all of C# and .NET collections. Okay, so far we've been working with one variable at a time, but real programs are going to deal with hundreds or thousands of items. Here's what we're going to cover in this video. First, we'll start off with why collections matter. We'll start by covering arrays and discuss their upsides and downsides. Then we'll move to more sophisticated collection types, and that'll bring us to lists. After lists, we'll cover a couple of collections that help with quick in-memory data retrieval, named dictionary and HashSet, and we'll wrap up with some thoughts on which type to choose. Okay, so let's say you're tracking student grades. In this sample, we're creating separate variables for everything. This is already kind of messy with 3 students. This is fine for simple stuff, but let's say you want to find the average grade. You couldn't just loop through individual variables, so you'd have to do it manually and add grade 1 plus grade 2 plus grade 3. That might be doable with 3 students, but let's think ahead a bit. Think about the way that this code would need to change. What happens when a new student joins? You'd have to go back and add student 4 and grade 4 to your code. What happens when you have 30 or 50 or 100 students? Yeah, it gets gross. There has to be a better way, right? There is. Let's look at arrays. When you start working with collections, you're going to notice that most, if not all, of the types you're using will be defined in these 2 .NET namespaces. System.collections and system.collections.generics. And then I suppose I should mention where the array data type is defined. That's defined in the system namespace. Anyway, when you start looking at code or you just want to go exploring, these are your go-to namespaces. Arrays are like a row of storage boxes. You decide how many boxes you need up front, and each box gets a number starting from 0. When you create an array with new int 5, you're saying I need exactly 5 boxes. That size is locked in. You can't add a 6th item later. This confuses everyone at first. The first item is at index 0, not 1. So in a 5-item array, you have indexes 0, 1, 2, 3, and 4. There is no index 5. An int array can only hold integers. A string array only holds strings. C# won't let you mix types, which actually helps catch bugs early. Every array knows its size through the length property. Super useful for loops. You don't have to remember how big the array is. Here's the error that gets everyone, and I mean everyone, when they start with arrays. When you create an array, you're getting a defined chunk of memory for use by the array. And when you declare it, you define its size. When I say size, I mean that you're defining how many items that array can contain. Let's say that you have this array, an array of strings with the length of 5. So then you go off and create an array of 5 items, then try to access grades item 5. Boom. Error messages. Your program crashes. It's a disaster, and it says something about IndexOutOfRangeException. Remember, a 5-item array has indexes 0 through 4, not 1 through 5. Your brain wants to think first item equals index 1, but in programming we start counting at 0. It's weird, but you'll get used to it. Once you create that 5-item array, it's always 5 items. Even if you only use 3 slots, you're still taking up memory for all 5, and you definitely can't add a 6th item. Create an int array, but don't fill it. All the values start at 0. String array? They're all probably null. This can lead to surprises if you're not careful. Arrays are great for fixed size data, but what if you don't know how many items you'll have? That's where lists come in. Arrays are limited by size, and that then brings us to lists. Lists are basically arrays with a superpower. They can grow and shrink. You don't need to know the size up front. Just keep adding items as you need them, call add, and the list grows. No need to specify size up front. Behind the scenes, it's managing arrays for you, resizing when needed. You can add to the end, insert at a specific position, or remove items. Try doing that with an array. You'd have to write a ton of code to shift everything around. And a lot of these types in system.collections have a method called addRange. addRange is helpful for when you want to add multiple items to a list at once. For example, copying items from one list to another list. Lists use count instead of length. Why? Because count can change as you add or remove items. It's a property that tells you how many items are actually in there right now. So when do you use an array versus a list? Let's talk through some of the key differences. Arrays are simple and fast. Lists are flexible and convenient. For arrays, you've got to know the size when you create it. Perfect when you know you'll always have exactly 12 months or 7 days. From a performance and resources point of vice, arrays have less overhead, but that honestly probably will never matter for you. If you've got millions of items, maybe. But for most programs, you'll never notice a difference. Arrays use exactly the memory they need. A 10-item array uses space for 10 items, period. But once again, for most applications, who cares? Add or remove items anytime and the list grows as needed. Lists come with lots of helpful methods like sort, reverse, contains, clear. If you want to do similar stuff with arrays, you'll probably end up having to write your own code for that. Lists work beautifully with LINQ. LINQ is a built-in query syntax in .NET. We'll cover it in more detail later, but for right now, just know that LINQ makes filtering and transforming data a lot easier. To wrap this comparison up, my guess is that you'll almost always want to use a list, unless you know you have a fixed number of items. Next up, dictionaries. Sometimes you need to look things up by something other than a number, like finding a phone number by someone's name. That's what dictionary is for. In this code sample, we're storing grades according to each person: Alice, Bob, Charlie, Diana, and Eve. Looking up Alice in a dictionary is almost instant, even with thousands of items. Try finding Alice in a list. You'd have to check every single item until you find her. Each key can only appear once. Try to add Alice twice, you'll get an error. This actually prevents a lot of bugs. No duplicate entries. The key doesn't have to be a string. You could use integers, dates, even custom objects. As long as C# can compare them for equality, you're good. Pro tip: instead of checking contains key, then getting the value, use try_get_value. It does both in one step and is more efficient. What if you're tracking which users have logged in today? You only care if they logged in, not how many times. That's HashSet territory. Add the same item twice. HashSet ignores the second one. Perfect for tracking unique values like user IDs, email addresses, or tags. Just like dictionary lookups, checking if something exists in a hash set is nearly instant, way faster than List.Contains gear for large collections. Remember sets from math class? You can do unions, intersections, and differences. Find users in both groups, users in either group. It's all built in. Here's the catch. HashSet doesn't maintain order. Items might come out in a different order than you put them in. If order matters, this isn't your collection. Okay, so we've seen arrays, lists, dictionaries, and hash sets. Let me show you how they all fit together in C#'s design. Don't worry about memorizing this. Just notice how they're all connected. See that IEnumerable at the top? That's why you can use for each on any collection. They all share this common foundation. It's like they all speak the same basic language. List and array both implement IList, which is why they both support index access with square brackets. Dictionary doesn't. It's a different branch of the family tree. The green boxes are interfaces. Think of them as contracts. The yellow boxes are the actual collections you create. Each class promises to fulfill its interface's contract. This is why LINQ works on everything. It uses IEnumerable. Now, knowing all this, how do you actually choose which collection to use? Okay, so we've got arrays, lists, dictionaries, and hash sets. How do you know which one to use? Let me give you a simple decision tree that'll cover 90% of your cases. Here's my simple flowchart for picking a collection. Start at the top and work your way down. First question, do you know exactly how many items you'll have, and will that never change? Like days of the week or months in a year. That's array territory. You need to look things up by something other than position, like finding a user by email or a product by SKU. You want a dictionary. Tracking unique items where duplicates don't make sense, like users who viewed a page or tags on an article, that's HashSet. Everything else? Use a list. Seriously, list is your workhorse. It's flexible, has tons of useful methods, and handles most scenarios beautifully. Let's build something real. A simple grade tracker that uses multiple collection types. See how we combined collections? Each student name maps to a list of their grades. Dictionary for fast lookup by name. List, because grades keep getting added throughout the semester. The hash set ensures each student only appears once in our passing list, even if we accidentally try to add them twice. No duplicate checking needed. This is totally normal. You'll often have lists of lists, dictionaries of dictionaries, whatever makes sense for your data structure. And notice that average guess method. That's LINQ, which we'll cover in the next video. It makes working with collections even more powerful. Before we wrap up, let me save you from the mistakes everyone makes with collections. You can't add or remove items from a collection while you're looping through it with foreach. C# will throw an exception. Use a regular for loop if you need to modify. Accessing a dictionary key that doesn't exist? Crash. Always check with contains key first, or better yet, use try_get_value. When you put objects in a collection, you're storing references, not copies. Change the object somewhere else, it changes in the collection too. This trips up everyone. Lists have hidden capacity. They might reserve space for 16 items even if you only have 3. Don't worry about it unless you're dealing with millions of items. Let's talk speed. Here's how fast these operations are with different collections. Accessing array is instant, no matter how big the array is. That's what O1 means. Constant time, usually instant, but occasionally list needs to resize its internal array. Still, we call this O1 amortized, fancy way of saying usually instant. Has to check every item until it finds a match. Got 1,000 items? Worst case, it checks all unopened. That's why we use HashSet for lookups. Finding grades, Alice is basically instant, even with thousands of students. This is the magic of hash tables. Just as fast as dictionary lookups. Checking if a user has logged in, instant, even with millions of users. Don't stress about this too much as a beginner, but knowing that HashSet and dictionary are fast for lookups, that'll save you someday. Alright, let's recap what we've learned about collections. When you know exactly how many items you need and that won't change, arrays are simple and efficient. But honestly, that's pretty rare. When in doubt, use list. It's flexible, has great methods, and handles 90% of scenarios. Don't overthink it, just use list. Need to find things by name, ID, or any other key? Dictionary makes it lightning fast. Way better than searching through a list. Perfect when you only care if something exists, not how many times. Automatically prevents duplicates and has super fast contains checks. Dictionary of lists, list of hash sets. Totally normal. Your data structures can be as complex as your problem needs them to be. Next up, we're going to learn about LINQ, which is going to make working with these collections feel like magic. Seriously, LINQ changes everything. Here's your homework. A simple challenge to practice what we've learned. Create a console app that manages contacts. Use a dictionary where the key is the person's name and the value is their phone number. Let users search for contacts by name. Use the dictionary's fast lookup. Also list all contacts using a foreach loop. Use a hash set to track which contacts are marked as favorites. Remember, hash set prevents duplicates automatically. Level up challenge. Instead of one phone number per person, use a dictionary of lists so each person can have multiple phone numbers. Don't worry if this seems challenging. The best way to learn collections is to use them. Make mistakes, get those exceptions, and figure out why. In our next video, we'll start to talk about something called language integrated query, or just LINQ for short. Anyway, thanks for watching this video, and hopefully you'll stay tuned for the next one.